This is section 7.4, integration of rational functions by partial fractions. So in this section, there are going to be 4 different cases. So let's focus on the first case first. So the first case is when you have linear factors in the denominator. So we have to break this up using partial fractions. So I'm going to rewrite this as y plus 4 in the denominator. Because this is a linear factor, that means the denominator has to be a constant, an arbitrary constant, which I'm going to call a. And for the second fraction, the factor is also linear, which means that the numerator also has to be an arbitrary constant, which I will call b, because it has to be different from the first fraction. Now we can multiply this by, now we need to get the LCD, the lowest common denominator, which is clearly y plus 4 times 2y minus 1, which means in this case we're going to multiply top and bottom by 2y minus 1. And over here we're going to multiply top and bottom by y plus 4. This is the method of partial fractions. Once again, after distributing, you're going to end up with 2ay minus a plus by plus 4b. Then you want to group all the y's together and then all the constants together. So if you do that, you should get 2a plus b in parentheses, factor out the y. So I grouped these two terms together because they both had a y. Now I'm going to group these two together because they're both constants. So I'm going to call that plus parentheses negative a plus 4b. All right, and of course we have the common denominator on the bottom. All right, once you get to this point, that's where you're going to go ahead and look at the fraction that you started with, and the coefficient is 1, which means that this coefficient must be 1, and there's no constant, which means this has to equal 0. So let's write those system of equations. So it's going to be 2a plus b equals 1. Once again, I got that from here. The coefficient is 1, which means this has to equal 1. And because there's no constant, this has to equal 0. So the second equation will be negative a plus 4b equals 0. Now you have a system of equations with 2 variables, so we should be able to solve. I'm going to add a to both sides, so this will become 4b equals a. Then I'm going to substitute the 4b into the a up here, and that'll give me 8b plus b equals 1, 9b equals 1, b equals 1/9. And if b is equal to 1/9, we can substitute that here. That means that a will equal 4/9. So we did that so that we could rewrite this integral and separate this fraction into 2 separate fractions. Therefore, that would make the integral much easier to evaluate. So the new integral will be, I'm focusing on this part now. I'm going to remove these factors that I added, and I'm going to rewrite this in this form. So the first fraction would be 4/9 for a, which I'm going to write outside of the integral. That would leave us with 1 over y plus 4 with respect to y. The second integral would be this one, the b, which is 1/9. I will write that outside of the integral. And we have 1 over 2y minus 1 with respect to y. Okay, and now we can go ahead and evaluate these integrals. So that's going to be 4/9 natural log absolute value of y plus 4 plus 1/9 ln absolute value of 2y minus 1 plus c. But because of the chain rule, this constant, we have to make sure that constant will be simplified out. So this means you have to multiply by 2 in the denominator, which would make that an 18. And that is going to complete problem number 1. All right, so that is our final answer for number 1, our first example. Now let's move on to the second case, number 2. Case number 2 is when you have higher powers in the denominator, which you will see. But first, notice that the degrees are equal. In the case where the degrees are equal, you have to do long division. For the first example, we didn't have to do that because this was second degree, first degree. So once again, if the degree of the numerator and denominator are equal, or if the degree of the numerator is greater than the degree of the denominator, then you do have to do long division. So let's do our long division. All right, if you do long division, that's going to be 1, which is going to give us x cubed plus x squared. When you subtract, that becomes a negative, and you distribute the negative here. This will also become minus here. Turns from plus to minus when you distribute. These terms cancel. This will give us 3x squared. Bring down the rest of the terms. So that's our remainder. So the quotient is 1 plus the remainder over the divisor. And so that's going to allow us to rewrite our integral as 1 over 2. The first part is just 1 with respect to x. The second part will be this one. So that's going to be plus the integral from 1 to 2. And I'm going to write that as 3x squared plus x minus 1 over. I'm going to factor out the x squared, which will leave us with x squared times x plus 1 with respect to x. As you can see, the degree of the denominator is now higher than the degree of the numerator. So therefore, we don't need to do long division anymore. That's the way it should be. And now we can do the method of partial fractions to separate this fraction and break it up into 2 separate fractions. So that's our next step. So let's do that now. So the first fraction will be x squared, which is a quadratic, which means that the numerator has to be linear. So because the denominator, the factor is squared, quadratic, that makes the numerator linear. For the next factor, the denominator is linear, which means our numerator has to be a constant, which has to be a different constant than the ones that we have over here. So I'm going to call it c. All right. And now we can go ahead and find the LCD, which is clearly x squared times x plus 1, which means we have to multiply the top and bottom of this fraction by x plus 1, x plus 1. Over here, we'll multiply top and bottom by x squared, x squared. After multiplying out, you should get a x squared plus a x plus bx plus b plus cx squared. Squeezing that in there. All right, and then once again, we're going to group those terms. So if you group the terms, you're going to get a plus c x squared. So that takes care of that term and that term. Then you group the x's together, you're going to get a plus b. I like to cancel those terms out so I know that I've used them. And then we have our constant, which is b. And now we've taken care of all the terms in the numerator. Denominator stays the same. And now finally we look back at this fraction and we look at the coefficients, and that's how we come up with our system of equations. So the first equation will be a plus c is equal to 3. So that will be a plus c equals 3. The next one will be a plus b equals 1. A plus b equals 1. And then the last one will be b is equal to negative 1, which is already solved. And then if you plug in negative 1 here, add 1 to both sides, you get a equals 2. And then if you plug in 2 for a, subtract 2 to both sides, you get c is equal to 1. Okay, now we're at the point where we can rewrite this integral into two separate integrals, this one and this one, just by replacing the a, b, and c with the values that we got. I'm going to rewrite this down here. I just got rid of the 1. The 1 you don't really need to write the 1. You can if you want. This fraction would become the integral of, from 1 to 2, of a, which is 2, so that's 2x plus b, which is minus 1, all over x squared, all right, plus c, which is 1 over x plus 1 dx. All right, and now at this point we can go ahead and I'm going to rewrite this integral. I'm going to split this up into two separate fractions, so this stays the same for now. This becomes 2 over x dx, and this becomes, actually that's going to be a minus because of the minus 1. I'm going to write that as, instead of 1 over x squared, x to the negative 2, which is the same thing. All right, so what I did here is I separated this fraction, which became this, and then I rewrote this fraction, which became this. But instead of 1 over x squared, I call it x to the negative 2. So now we can finally find the antiderivatives. This is going to be x from 1 to 2. This is going to be 2 ln x, from 1 to 2. This is going to be, if you take the antiderivative of that, that minus 1 is going to turn that into a plus. That's going to be x, well, that's going to be x to the negative 1, which is 1 over x, 1 to 2. And then over here we have ln of x plus 1 from 1 to 2. Finally, we can evaluate. Plugging in 2 minus 1 is 1. Over here, you're going to have 2 ln 2 minus 2 ln 1. Over here, you're going to have 1/2 minus 1. And over here, you're going to have ln of 3 minus ln of 2. All right, and now combining like terms, well, it looks like this one and this one will cancel. Ln of 1 is 0. And then you can combine these two ln's. And so we're going to end up with 1/2, which is that one. And then we're going to end up with 1 ln of 2 plus ln of 3. So I combined this one with this one. That's where I got the ln of 2. And then this one I wrote separately, and the 1/2 I wrote separately. So that is our final answer. Okay, so that is that. So notice you could also, if you wanted to combine these two natural logs into ln of 6, that's also something you could have written, or 1/2 plus ln of 6 if you wanted to get a little fancier. All right, so that will do it. Let's move on to the next section. The next case is case number 3. In this case, you always want to check, make sure the degree of the denominator is bigger than the degree of the numerator, which it is, so we don't have to do our long division this time. We can factor out the LCD, which is going to be that, and then we can separate these. X squared plus 3 is a quadratic, which means the numerator has to be linear, which would be ax plus b. And then for the other factor, which is x, there's two factors, 1, 2. For x, since that's linear, that means the numerator has to be constant, which is c. All right, then we get our common denominator, which is x squared plus 3. Over here, we're going to multiply top and bottom by the missing factor, which is x. And then over here, the missing factor is x squared plus 3, x squared plus 3. After distributing, we should get ax squared plus bx plus cx squared plus 3c. All right, and now once we are at this point, we can look at the coefficient. Oh, actually, we have to group the x squares together. So a plus c x squared, that would be these two. And then the x's go next, which is just bx. That would be that term. And the constant goes last, which is 3c. That would be that term. Now, at this point, we can, let me just write out the denominator. Now we look at the coefficients. A plus c must equal 1, b must equal -1, and 3c must equal 6. So that's our system of equations. A plus c must equal 1, b must equal -1, and 3c must equal 6. This one's solved already. C is going to equal to 2, and that would make A equal to, if C is 2, if you subtract 2 to both sides, you get -1. All right, so now we can rewrite the original integral and separate it using this here, these two fractions, the partial fractions that we, whoops, that I did not mean to do that, but that's okay, I can fix that. All right, so now we can rewrite this using the constants that we found. So the new integral will be integral of ax plus b, which is -x minus 1 over x squared plus 3 dx, plus c, which is 2 over x dx. All right, so we rewrote the original fraction by partial fractions. We broke it up into this, which turned out to be this after we plugged in the constants. All right, this one here, we're going to have to split this up into two separate fractions, this minus this. So let's rewrite that as -x over x squared plus 3 dx minus 1 over x squared plus 3 dx. And then the last fraction is just 2 over x dx. All right, for this one, this is a u substitution problem. U is equal to the denominator, which means du is equal to 2x dx, which means 1/2 du is equal to x dx, which will allow us to substitute in for this. So that's going to become -1/2 on the outside. That's going to be 1 over u du. All right, which is going to be -1/2 natural log of u, but u is really x squared plus 3. So this is just the absolute value of x squared plus 3. But notice that I switched it from absolute to parentheses because the square makes this a positive number. Plus 3 is just a positive number. So we don't really need the absolute value. We can just change it to parentheses. Moving on to this one. So the reason why I put this in the notes where I put it is because that's where we're going to apply it. So the integral of 1 over x squared plus a squared is equal to 1 over a inverse tan of x over a. So we can use that here for this problem. So a squared is 3, which makes a the square root of 3. So this is going to be minus 1 over radical 3 inverse tangent of x over radical 3. I just simply applied this. A is radical 3, and that's where I got that from. All right, and then the final integral is 2 over x, which is just 2 natural log of absolute value of x. And don't forget your c. And that is our final answer. All right, so that was a long problem, but we got through it. And now let's move on to the final case, which is case number 4. All right, case number 4, here we go. So case number 4, first let's check the degrees. The degree of the top is 3. The degree of the bottom, that's 4 times 1, that's going to be 5. So the denominator has a higher degree than the numerator, which means we don't have to do long division. All right, so let's rewrite this as, using partial fractions, we need to split this fraction up into multiple fractions. So because this one is a square of a quadratic, that means you have to go up to two different terms here. One to the first and then to the second because of this exponent. So let's write that out. I'm going to start with the square term first, and then I'll move down to the power of 1. So for this alone, you have to write it twice, one for the 2 and one for the 1. And then for the last fraction, it's just a denominator of x, which is linear. So this is quadratic, so you have to use ax plus b, which is linear, and then here you have to do cx plus d, which is also linear, and here you have to use e for a constant. This is linear, therefore this is constant. This is quadratic, therefore this is linear. This is quadratic, which means this is linear as well. And you can see that here. All right, and now we have to do our common denominator, which is here, as you can see. So, which means I need to multiply top and bottom by x. For the first term, times x. Over here, I'm going to multiply top and bottom by x squared plus 1. And over here, I'm going to multiply top and bottom by x squared plus 1 squared. Okay, so there's a lot of algebra for this problem. So that's going to be ax squared plus bx for the first one after I distribute. For this one, I'm going to go ahead and just write out what I ended up getting for that. Save us a little bit of time. So let's see, it turned out to be cx to the 4th plus cx squared plus dx cubed plus dx. And then after doing this, I ended up getting ex to the 4th plus 2ex squared plus e. All right, and then when you group everything, you're going to end up with c plus e x to the 4th plus dx cubed plus a plus 2e x squared plus b plus d x plus e. All right. Oops, actually I forgot a term here. Sorry about that. I forgot here to squeeze in the c. Plus b plus d x plus e. So I should have gotten them all. Let's see. The 4th powers are that and that. I got those two. Cubic, it's just one term. The square, there should be 3. That one, and that one, 3 terms. And then the linear terms, there's 2. And then the constant is just 1. All right, at that point, we can look at the original and look at the coefficients. So the 4th power, there is no 4th power. Since there's no 4th power, this has to be equal to 0. So that'll be our first equation for our system. And once again, this is to the 4th power, but because there is no 4th power, that's why this has to equal 0. The cubic, the coefficient for the cubic is -1. So this has to be -1. D must equal -1. For the square, that has to equal to 2. So this has to equal to 2. Oops. A plus 2e plus c must equal 2. And then for the linear term, it should be -1. So b plus d must equal -1. And finally, for e, the constant must be +1. All right, so now let's substitute and solve. So if you plug in 1 for e, that's going to be c is equal to -1. All right, if you plug in -1 for d, and then you add 1 to both sides, you're going to get b is equal to 0. And then the last one we need to solve for is a. So a, if this is a 1 and c is a -1, that's 2. That's 2 minus 1 is 1. subtract 1 to both sides, you should get a equals 1. So let's see, that looks good. Yes, that is correct. Very good. All right, so we solved everything. Now we got to go back and rewrite our new integrals. There's 3 fractions, so our new integrals should look like this. The first one is going to be, I like to erase these just to make it look a little bit easier to substitute back in. All right, so this fraction is going to be ax plus b, which is ax plus b, there is no b, b is 0, over ax squared plus 1 squared. All right, the next integral will be cx plus d, so that's negative x minus 1 over x squared plus 1 dx. And then the final is the integral of e over x dx. So we have 3 integrals to integrate. This one is fairly straightforward. This one we need to split up again and use the inverse tangent. And this one we have to do a u substitution. So let's focus on the u substitution first. All right, so this integral now, the first integral will become 1/2 u to the negative 2 du. So this, through the substitutions, becomes this. All right, which means that that would become negative 1/2 1 over u, which is 1 over u, which is x squared plus 1. So that will be our first antiderivative, this here. All right, now let's move on to the second one. This one, we have to split into 2 separate fractions, that and that. So let's do that now. So that's going to become minus x over x squared plus 1 dx minus 1 over x squared plus 1 dx. And then the last one's very straightforward. It's just going to be natural log. So I wrote this one down here. So this one here became that and that. I split it up into 2 separate. Here's another u substitution problem. Oops. All right, so that is going to become negative 1/2 integral 1 over u du, which is just going to be negative 1/2 natural log of x squared plus 1. I'm going to, instead of the absolute value, I'm just going to change it to parentheses because this is a positive number. So this is the second integral. So maybe I should circle these. So first integral, second integral. Now we're here. That one is just this formula where a is 1. A is 1 because a squared is 1, therefore a is 1. So this is going to be negative tangent inverse of x. And then the final one is just natural log of absolute value of x. So there we go. We have all 4 integrals worked out. So let's see if we can put it all together in one final line. So negative 1/2, let me write this as negative 1 over 2x squared plus 1 minus 1/2 natural log x squared plus 1. I'm going to go ahead and erase this to create a little bit of space. Minus tangent inverse of x plus ln of absolute value of x plus c, constant of integration. And that is our final answer. That's a long answer, but yeah, some of these problems can be kind of long, like that one. And that is it for this